Hello, and welcome back for a new episode of Reer Academy. Today we are going to explain what a safety relay is and why the EDM function is important to us. Let's start with the definition of a relay, and later we'll see how a safety relay works in an industrial context. We all know how a standard relay works, don't we? The relay is an electromechanical device similar to a switch, with a mechanism operated by the passage of electric current in the coil. Once energized, the electromagnet attracts the anchor connected to the movable contact, that will then change position, from open to close for normally open relays, and from close to open for normally closed relays. Here you can see an example of normally open relays with two contacts, one movable and one fixed. When the relay is at rest, the movable contact is open. When the electromagnet is energized, that is, when an electric current is flowing through the coil, the situation reverses and the movable contact closes. In this situation, the machine connected to the relay starts. In the opposite scenario, when the electromagnet is no longer energized, the contact opens and the machine stops. The opening and closing of the contacts is called commutation. When we talk about safety, a subject we like a lot, we talk about relays with forcibly guided contacts or safety relays. This is because there are multiple contacts mechanically connected to each other, typically with contacts open at rest, normally open, used for safety-related functions like stopping and starting a machine, and contacts closed at rest, normally closed, generally used for status and feedback functions. All contacts must move together, so if a normally open contact closes, the normally closed contact opens, and vice versa. I really needed this. When the electromagnet receives electrical current, the contacts move from rest state to energized state. The circuit closes and the machine restarts. You may be wondering why these contacts are mechanically connected, precisely to increase their safety. Let me explain this concept in more details. To safely stop the operation of a machine, for example, the power supply is interrupted by two different contacts. Both of them then open and come back to their normal positions. To reach the highest safety levels, for example BLE, the machine directive implies that a redundancy circuit is always used. Therefore, two safety relays are used, and even if one of the two would break, the other would still open the safety circuit. The opening of the circuit is therefore guaranteed by the redundant relay, and the single failure on one of the safety relays does not compromise the overall safety of the machine. In fact, the machine directive defines that two faults cannot occur at the same time, unless there is a common cause failure. The machine designer must take this type of failure into consideration and exclude it at design stage. For example, an overcurrent flowing into both relays contacts could weld both of them. In this case, we must protect the relays with a fuse that will blow, interrupting the current before the relay contacts weld. When the primary contact moves to open position, the machine stops. If it remains stuck, and therefore closed, the secondary contact still opens and, in combination with a special monitoring function, detects the malfunctioning of the relay. This function is called EDM, External Device Monitoring, and is also known as feedback function. It ensures that the external device, for example a safety relay, connected to the safety device, for example a safety light curtain, can interrupt the safety circuit and eventually stop the machine. The safety relays provide feedback through the normally closed auxiliary contacts connected in series and forcibly guided by its normally open safety contacts. When a fault is detected, this circuit prevents the reset of the safety device and therefore the restart of the machine. Do you feel that you now understand how this process works? I'm sure you do, but I think I need another coffee. Time flies when you have fun, isn't it? We are done for today. I look forward to seeing you in the next episode of Reer Academy.